Hello everyone. We know that temperature and humidity are the major factors of environment. So today we are here on a project of measuring temperature and humidity using Arduino. I am Angel Stanislaus.
I am Ida Paulos.
I am Sonia Paul. We all are doing our second year BTech degree in Electronics and Communication at Christ College of Engineering.
We know that Indian industries majorly include agriculture, biomedical and pharmaceutical, which are the pillars of Indian economy. Measuring of temperature and humidity are the major areas of all these industries.
Any kind of unbalancing in the environmental conditions can create financial loss in the productivity of pharmaceutical and agricultural industries.
In this project, we are going to measure the temperature and humidity using Arduino tool and also DHT11 sensor, which would increase the productivity of the environment.
The components required for this project are a 5K ohm resistor, a DHT11 temperature and humidity sensor, a 10K ohm potentiometer, an Arduino, an LCD 16x2 and a breadboard.
DB4 to DB7 of LCD is connected to digital pin 5 to 2 of Arduino respectively.
VSS of LCD is connected to the ground of the breadboard. VCC of LCD is connected to positive of breadboard. VEE is connected to output of potentiometer.
Ground of the sensor is connected to the ground of the breadboard. Data pin of the sensor is connected to the digital pin 7 of Arduino. VCC of sensor is connected to the 5 volt in breadboard. Breadboard is powered using Arduino analog 5 volt and ground. Now let's see the working. The project consists of 3 sections. In the first section, we measure the temperature and humidity using the DHT11 sensor. And in the second section, reads the DHT11's sensor's output and then extract the temperature and humidity in suitable values in percentage and Celsius scale. And in the third section, the temperature and humidity is displayed in the LCD display. First, the Arduino sends a start signal to the DHT11 and the DHT11 in response gives a signal containing data of temperature and humidity. The Arduino extracts it in 2 parts. The first one is temperature and second one is humidity and then send it to LCD display.
Now let's have a look at the working of the DHT11 sensor. The DHT11 detects the water vapor by measuring the electrical resistance in between the 2 electrodes. The humidity sensing component is a moisture holding substrate with 2 electrodes applied to a surface. When water vapor is absorbed by the substrate, ions are released by the substrate, which increases the conductivity between the electrodes. The higher relative humidity decreases the resistance in between the electrodes, while the lower relative humidity increases the resistance in between the electrodes.
The DHT11 measures the temperature on the surface-mounted NTC temperature sensor, which is built into this unit. An IC is mounted on the back of this unit and also stores the calibration coefficient and at the same time changes or transmits the data from or between the Arduino and DHT11. The DHT11 uses one signal wire to transmit the data to Arduino. The power comes separate from the 5 volt and ground wires. A 10K ohm pull-up resistor is provided to make sure that the signal level stays high by default.
To study the performance characteristics of the used Arduino-based humidity and temperature sensor, the test was done in 3 different conditions. The first test was done inside a room and the second test was done outside the building and the third test was done inside a refrigerator. We can see how the temperature and humidity varies in 3 different conditions.
So, our work was successful in building a monitoring device which works as a thermometer which measures temperature and humidity in a building. It is also capable of measuring temperature and humidity in outdoors.
Compared to expensive sensors, Arduino-based monitoring system successfully reduces the power consumption, cost and complexity of the process. The performance of the system was accurate and reliable with some error in measurement and limitations of the sensor used.
Arduino-based the monitoring devices are the new possibilities for developing smart devices with simple cost and smart works.